where we had convergence at the surface, namely the ITCZ, and then rising motions, and then divergence aloft. We're going to watch for these patterns, though. Both of these things. So far, we've only talked about the tropics. But we got like half the world to go, right? So we're going to be watching for these patterns. In the meantime, though, I think these diagrams have gotten a smidge complicated. Let's shift and talk about the poles instead. We'll work our way towards the middle, but we're going to start at the poles now. All right, wait a minute. 1, 2, 3. Try to save these notes for a student last one. 1, 2, 3, 4. All right. I am so accommodating to people who would tell me they're not going to be here. There we go. All right. We talked about the fact that Sir George Hadley said that air should be sinking at the poles. And he was right. I doubt good old George knew much about the business of the ideal gas law and knew that as air got colder, the same pressure became more dense and therefore was more heavy and it sank. But he knew that cold air sank. He probably had, drafts in his manor house or something. He knew that cold air sank, and he's right about that. And just from our ideas now about cyclones and anticyclones, if we're thinking about sinking motion, we probably realize that that means that there must be high pressure at the surface. And we would be right about that. Generally speaking, both the North Pole and the South Pole are areas of high pressure. And this, again, is not like the weather. The weather here in Omaha, we have areas of high pressure and low pressure moving through every few days. Not like that at the poles. It's pretty much permanently high pressure there. In fact, we have a name for those things. Those are called the polar highs. And there's two of them. There's one in the northern hemisphere, and there's one in the southern hemisphere. They're pretty darn strong highs, by the way. Hey, high pressure. When I think of high pressure, I think of like no rain or no precipitation. But when I think of the North Pole, I think of it, being deep snow and ice and stuff like that. Hey, how can that be, right? I mean, if it's high pressure, shouldn't it be dry there? Well, it is dry there. I mean, like Antarctica, right? You think about Antarctica, you think of all the snow, right? I've seen March of the Penguins. I know that there's lots of snow there, right? No. In fact, the Antarctica and the Arctic are deserts. They only get maybe an inch or two of snow a year. Most of what you're seeing there, that's been there a while, right? There's not a lot of melting going on there. The wind's just been pushing that same snow around, blowing it against the penguin, the mother penguin that's sitting on the egg or whatever. Okay, that snow fell a long time ago. That's not falling right now. Antarctica and the North Pole, they are serious deserts. Very little precipitation falls there. If that's going to be an anticyclone, a high pressure system, it's an anticyclone, which means the air is going to be flowing around it in a clockwise manner in the northern hemisphere. That's a little hard to draw. If I can do this here better. If we were looking at this from above, like we were in a rocket above the North Pole, we'd be looking down on the North Pole and we would see that the winds are going around it clockwise. Again, permanent. It's like that all the time. That's not anything like the weather here. Winds go from every different direction. But if you're up there near the North Pole, you see that the winds are pretty much always from the east. They are the polar easterlies. Again, working with this idea that we describe winds in terms of where they come from. So the polar easterlies are winds that are from the east. And so if you happen to be up in places like northern Canada or something like that, the winds are pretty much always from the east. Now, if I keep adding in features here that we had at the surface, remember, at the surface, and in the subtropics, we have these subtropical highs, with their flow being clockwise. And this warm air that's coming from places like Florida and Central America flowing up And notice that there's this polar high up here near the North Pole with cold air flowing to the south. So see how, like, if we look at this from the side, we see that we have cold air flowing from the north, and it's meeting warm air that's flowing from the south. See how these are the same winds, by the way? So like this wind here is these winds being seen from the side. And this wind here is like these winds being seen from the side. And notice that something very interesting and complex is happening right here, where cold air from the north is meeting warm air from the south. And in fact, that's happening all the way around the world at the surface, right about here. There's like a boundary, a place where air is converging at the surface, a place where cold air from the north is meeting warm air from the south. Hey, and it seems to be happening right on top of us. We better figure out what that thing is, considering it's happening right here. This is going to be our first example of what we're going to call a front. It is not a front. I mean, how should I put it? Let me give you the punchline there. It's something that we're going to call the polar front. The polar front is not a term you've heard before. When you watch the weather, and I know you guys are watching the weather religiously now. When you watch the weather, you are hearing things like cold front and warm front and stationary front. Those things are examples of the polar front. Okay, so think of, I mean, whether it's cold front or it's warm front or it's a stationary front, it's an example of a polar front. It is a boundary between cold air from the north and warm air from the south. Okay, we're going to spend like a whole day talking about cold fronts, warm fronts, stationary fronts, occluded fronts, and dry-line fronts. Not until after spring break, though, I think. In the meantime, though, we've got this idea of a front. This word front tends to be a little bit awkward because we have the connotation of the word front as in opposite to the back. That's not the word that they're talking about here. When they talk about a front, they mean a front like a military front. Okay? The German front versus the Japanese front or something like that at a battle, where armies from one side are meeting armies from another side. And this was actually the original idea behind the word front in a meteorological sense. They had this idea that like the cold air from the north was invading, and it was meeting the warm air from the south, which was trying to push the other way. And in fact, that idea is not terribly horrible, but it is where we got the idea. Okay, this idea of a front. It's a boundary. It's a battle line. Looks like it's an area of convergence to me. Convergence at the surface. Now, we still don't have the whole thing put together. There's a few more things that are going to connect the dots between the tropical general circulation we learned about in the first half of the hour and this polar type general circulation that we've seen here, because we need to start connecting all of this. Okay? But we have to move to a different topic because we're about to run out of tape. Okay? So, what's going to happen is we have to switch over now to a PowerPoint thing that the students who aren't here today can just get the PowerPoint, and then we will continue this on Tuesday. Okay, so this is a natural breaking spot. We're going to stop talking about general circulation for a little bit, until Tuesday actually, and we're going to switch now and talk about, hold on just a second. Oh, let's just look at some of these diagrams. Oh, most of these actually don't show up very well on the stupid projector. If you go to today's Blue Line page and you look, there's lots of maps that show examples. Here's a lovely subtropical high pressure system. Here are some examples of jet streams, whatever. Most of these maps don't project very well on this cheap projector. Oh, not so much cheap, but old. So you might have better luck looking at them as examples on your computer at home where you'll see the colors more sharply than they see on here. Okay, so I would recommend doing that. All right, if I were to, I guess, minimize this, go over here. One of the tools that we're going to be using for the rest of the semester, much more than we did in the first half of the semester, is satellite imagery. Once in a while we have something that involves a satellite picture, but we're really going to start using it a lot. So, we need to be